Hello students, I am Dr. Ashish Vikhar and I am presenting here another important chapter of power engineering and refrigeration, and the name of the topic is 2.2 Combustion in SI engine. SI means spark ignition engine. Before proceeding to the lecture, I would like to appeal you that to subscribe my YouTube channel. My channel name is Knowledge Link, and inside the bracket you will see that there is a name given Dr. Ashish Vikhar. So YouTube channel name is Knowledge Link, or you can visit my website also www.drvikhar.com. So today's topic of learning is how is the combustion in SI engine takes place. As you can see in this picture, combustion is taking place with the help of fuel plus air mixture. Once the combustion starts, you will see that power is going to generate inside the internal combustion engine, and after combustion exhaust gases are sent to the atmosphere. In this process of combustion inside the SI engine, you will see that one of the important component on the right hand side, which is called as a carburetor. So carburetor is an important element for mixing of air as well as fuel. So let us see one in detail how is the structure of combustion in SI engine. In SI engine or spark ignition engine, air and fuel mixture is a proportional ratio and is supplied to the combustion chamber with the help of carburetor. This air fuel mixture in the combustion chamber is ignited using the spark plug, which provides a high intensity spark. This spark initiates the combustion process in the combustion chamber. So carburetor and spark plug, these are the two important devices which plays an important role in a combustion chamber of SI type of engine. So the process of combustion can be theoretically represented with the help of one important diagram that you can see in front of you. This diagram is nothing but pressure versus the crank angle. So pressure is plotted on vertical y-axis, and horizontal line at the bottom you can see the crank angle. On the horizontal line you will see that the crank angle in degrees at the start is 0, at the middle it is 180, and at the end you will see that 360 angle is given, and the pressure is presented on y-axis, which is nothing but one vertical line at the middle of this crank angle line. So this is nothing but a way of presenting combustion process inside the SI engine, theoretical representation. You can see that there are three lines or curves plotted: A to B, B to C, and C to D. So this A to B, B to C, and C to D is nothing but a theoretical curve for representing a combustion process inside a spark ignition or any type of engine. So in a pressure versus crank angle diagram of the 4-stroke spark ignition engine, you will see that AB is the compression process. So A to B, as you can see in this picture, the curve is representing the compression process. So A to B is a compression process, B to C is the combustion process, and C to D is the expansion process. As you can see that the pressure rise during the combustion process is at constant volume in a theoretical cycle. So this figure in front of you is a theoretical presentation of a combustion that is taking place inside the spark ignition engine. The combustion process of SI engine can be divided into three broad categories. One is nothing but number one is ignition and flame development. Number two, flame propagation, and number three is flame termination. So flame development is the first stage, flame propagation is the second stage, and flame termination is the third stage in case of SI engine in case of these spark ignition engines. So here you will see the stages of combustion in SI engine in detail. To understand the combustion phenomena in SI engine, Ricardo, one of the famous scientists, carried out an experiment using a quad cylinder and high speed photography. In the above figure you will see that the curve A, B, M, N is a motoring curve, and this curve is plotted when the engine is not under firing. Another curve you will see that A, B, C, D is a combustion curve when engine is in the firing. So these are the two curves that you can see in this picture. First curve is a motoring curve and second curve is a combustion curve. A, B, M, N is a motoring curve, and the condition is that when the engine is not firing, while A, B, C, D is a combustion curve when the engine is under firing. So on the basis of the experiment done by Ricardo, there are three stages of combustion in SI engine. Number one is preparation phase, second one is a flame propagation phase, and after burning. So these are the three important stages: preparation phase, number two is a flame propagation phase, and after burning. So preparation phase, as you can see, the preparation phase is also called period of ignition lag. So period of ignition lag is also called as a preparation phase. This is the first stage in the combustion stages in SI engine. According to the experiment, there is some time interval between the first spark given to the mixture, and this is at the point number A. So point A is representing the point of first spark given to the mixture, and after that the flame appears out of the mixture. So these are the two important points, which is starting with the point number A. Point A is nothing but representing first spark given to the mixture. So there is some time interval between the first spark given to the mixture at the point A and the first flame appears out of the mixture. This time interval is known as an ignition lag. So period of ignition lag or preparation phase, and it is represented on this diagram of pressure versus crank angle by the line AB. So AB is the representing of preparation phase, or it is also called as a period of ignition lag. So due to this combustion, there is a clear rise in cylinder pressure. The ignition lag represents the pre-flame reaction. According to the chain reaction theory of combustion, in pre-flame reactions, chain carriers are produced. During the period AB, the angle changed by the crank between the point A and B is known as the ignition delay angle. This first phase or preparation phase in the stages of combustion of SI engine depends upon the different factors such as temperature of the fuel, pressure, molecular structure of the fuel, density, and air fuel ratio in the combustion chamber. Second stage is flame propagation phase. So when the first flame appears after the spark at the point B, this flame travels surrounding and burns the fuel in the different layers. This fuel burning rate and flame speed are noticeably low, and there is a small but steady pressure rise in the combustion chamber. This burning of air and fuel in the combustion chamber continues further, and it causes a continuous rise in pressure and temperature. It releases heat in the combustion chamber, which is transferred from burned to unburned charge. The speed of flame propagation is becoming very high in the range of 15 to 35 meter per second. So in this way, we can have the information regarding the second stage, which is called as a flame propagation phase. So differentiating between the first and second phase, that is preparation phase and flame propagation phase, is quite a difficult task. But you can distinguish between these two phases by observing the P theta diagram. So the second phase, that is flame propagation phase, starts when the pressure in the combustion chamber starts rising at the point B, and phase ends when the highest pressure is achieved in the cylinder at the point C. So point C in the P theta diagram is nothing but the representation of highest pressure. So curve BC on this diagram represent the rate of pressure rise. The rate of heat transfer to the cylinder wall is very low at the beginning of the flame propagation phase. This stage is one of the most important stage in the stages of combustion in SI engine. Third stage is nothing but after burning. We attain the point C in the second stage of the combustion, but it does not represent the completion of the combustion of the mixture. Because of the continuous burning of remaining fuels in the cylinder and reassociation of dissociated gases in the combustion chamber. During the expansion stroke, the combustion of air and fuel mixture continues after point number C. This phase is called after burning. After burning represents the third stage of combustion in SI engine up to the point D in case of P theta diagram. During after burning phase, flame velocity reduces to certain level. This was the last phase of the stages of combustion in SI engine. So what is the conclusion of this particular information? In this article or in this lecture, we have discussed three various stages of combustion in spark ignition engine, such as preparation phase, flame propagation phase, and after burning, using P theta, means P means pressure and theta means crank angle diagram, and that is represented in the above slides. So that the diagram or map is drawn using the values from the Ricardo experiment. So in this way we have seen this diagram, which is nothing but shows you the stages of combustion in SI engine. So this diagram is very important, and three important stages that we have seen. Thank you very much. Please subscribe again. I will try to request you all to please subscribe my YouTube channel, Knowledge Link. Thank you very much.